This is 7.1. In Chapter 7, we're only going to do 2 of the sections. The other sections have to do with adding, and we've spent time doing adding. But these are the only 2 sections that we're doing in Chapter 1, 7.1 and 7.5. 7.1, we're going to talk about exponents, how to multiply them. Now, you already kind of know how to do this, but we're going to show you a shortcut way to do it, that you have a choice now. Let's remind ourselves what an exponent means. An exponent means a power, and it's that little number in the air. Remember that that little number in the air does not mean that you take that number times your base or your big number. It means how many of your base. For example, x to the third means you got x, x, x. You have 3 x's multiplied, and that's why it's x to the third. If I had 2 different bases, x squared and y third, well, the 2 goes with the x, so that means you had 2 of x's, and the 3 goes with the y, so that would mean you had 3 y's. And we did this back in Chapter 1, so just kind of keep that in mind. Now, we've talked about before that every time we learn something, that 0 and 1 are kind of weirdos, kind of exceptions to the rules. And so let's talk about those real quickly. If it's got a power of 1, for example, if it's x to the first power, remember we just wrote that as x. We didn't write that understood 1. But you need to know that anything with a power of 1, whether it's a letter or whether it's a number, is just going to be one of those numbers. And if I give you this, that there's always an understood 1 there, we just don't write it. Now, the one that's unusual is what if it's a power of 0? For example, if I have x to the 0 power. Well, that meant that when you were factoring and canceling stuff out, that all of the x's went away. Remember, when you did that, if everything went away, when you multiplied, it turned into just 1. So by definition, anything to a power of 0 is going to be 1. X to the 0 power is 1. 3 to the 0 power is 1. A negative 2 to the 0 power is 1. Bananas to the 0 power is 1. Anything that's got a power of 0 is just going to be equal to the number 1. So remember that as you simplify these, okay? All right. Now we're going to talk about how do we multiply when I have powers. If you have x to the second and you're multiplying it times x to the fifth, well, if we use the definition, x squared means xx. X to the fifth would mean that I had 5 x's. So if you put that all together, you're going to end up with x to the 7th. Everybody agree? Well, now there's a shortcut here. Well, how do you get 7 from x squared times x to the 5th? Well, you took 2 of them and you added 5 more, and that gives you x to the 7th. So your new shortcut is that you can add the powers of like terms. So even though it's a multiplication problem, you can add the little numbers, and that would be a shortcut. Now, if you want to spread it out and do it that way, of course, you're welcome to do that. Or you could try using the shortcut. So let's look at this problem. If I have negative 2x to the 6th y times 5xy squared, spreading all of that out is going to look pretty long. You got negative 2, and then you've got 3 x's, and you've got a y. And then you've got a 5, 1x, and then a pair of y's, right? Now then you've got to put it all back together. If you take negative 2 times 5, that gives you negative 10. Well, how many x's do you have altogether? Well, you had 6 of them, and 1 more, that gives you x to the 7th. And if you look at your y's, well, you had 1 y here and 2 more y's, that gives you y to the 3rd. So if you can use this little shortcut, multiply the big numbers, but then add the little powers on each of the letters. Remember that this x has an understood 1. So if I'm doing this problem, x squared y cubed z5 times x y4 z4, let's try using the shortcut. On my x's, well, I have 2 of them here plus 1 more. For your y's, you've got 3 of them here plus 4 of them. And for your z's, you've got 5 of them here and 3 more of them. So that means you're going to have x to the 3rd, y to the 7th, and z to the 8th. So you could use the shortcut instead of writing them all out and counting them all back up and figure out what it would be. Now, what happens if you have x to the 0 times y? You'll notice that the bases are not the same, so I don't add the powers together. You only added the powers of the ones that had the same base. And if you have x to the 0, well, we just said that anything to the 0 power, this is just going to turn into 1. So what is 1 times y to the 5th? Well, that's just going to be y to the 5th. So if you ever get a base that has a 0 power, you know that it cancels into just being 1, and that's going to simplify your answer. Now, what happens if we have something that's called a power of a power? In other words, you have a power in a pair of parentheses, and look, I have this little power sticking out here all by itself, okay? So this means that I want 3 of what's in the parentheses. If you expanded it, that would be x squared, and x squared. And then use your new shortcut. You got 2 of them, and 2 more of them, and 2 more of them. That gives you x to the 6th. Okay? If I have x, y squared, all in parentheses to the 3rd power, that means I want xy squared, xy squared, xy squared. I wanted 3 of all of the stuff that's in the parentheses. So when I do that, I'm going to put my x's all together. I got 1 of them here, 1 of them there, and 1 of them there. That gives me 3 of them. And for my y's, I've got 2 here, 2 there, 2 there. That gives me 6. Okay? Well, let's look at this. What shortcut could I have used instead of expanding it and then doing it? Well, the shortcut is, if it's a power of a power, it's kind of like you're going to distribute that power. Okay? So if I have a little 3 here on a pair of parentheses, it's like I distributed that 3 into the power, and 3 times 2 is going to give me 6. Well, that's exactly what I got. If I'm going to distribute this one, remember your x has an understood 1, so you're distributing that, and you're distributing. That gives me x to the 1 times 3, or y to the 2 times 3, or y to the 6th. So you can either expand it and then use it, or you can use this idea of distributing my power, okay? And in 7.1, they're trying to get the idea of distributing, okay? If I have 2x squared y, all in parentheses to the 2nd power, let's try to use my shortcut. I'm going to take the 2 and distribute it to the power of the 2. Well, what is this one's power? Remember, it's an understood 1. So that'll be 2 to the 1 times 2, and then x to the 2 times 2, and y, remember, it has an understood 1. Okay? So 2 to the 1 times 2 would be 2 squared. X to the 2 times 2 would be x to the 4th. And y to the 1 times 2 would be y squared. So this would be my basic answer. But I'm not going to leave a number with a power. What is 2 squared? Oh, well, that's 4. And so my final answer would be 4x to the 4th y squared. So if you can use the shortcut, try to do that. If the shortcut doesn't make sense to you, spread it out. Multiply the big numbers times the big number. Collect your x's and collect your y's. Now, what happens if I have something in parentheses to the 0 power? Okay? Am I going to distribute? How many times do I write it out? Well, you have to remember your rule over here, your weirdo rule. Anything to the 0 power is going to be equal to 1. Even if it's a whole bunch of stuff. Remember, we said bananas to the 0 power is going to be 1. So anything to the 0 power is going to end up just being 1.